Welcome everybody to the next episode of the Cannabis Review. I'm delighted to be joined in this episode by Dr. Markus Roggen, who's the president and CEO of Delic Labs. How are you keeping today, Markus?
Thank you very much. CSO, CEO, I gave up that job to a more business-minded person, so I can focus on the science.
Yeah, okay, very good. Do you want to give everybody a quick little overview of how you ended up in the cannabis industry and at Delic Labs?
Okay, this is a quick 15-minute talk, so that won't be the full story. But in short, I have a PhD in chemistry, and then serendipitously, while I was doing my PhD, my postdoc in California, I got into the cannabis industry. It was recreationally legal in Colorado at the time and medically legal in California, and so my my chemistry skills brought me into the field.
Well, what is it exactly that you guys specialize at your laboratory?
So we are in Vancouver, Canada, so that we can get research licenses from the Canadian government on cannabis and psychedelic compounds. And we partner with the University of British Columbia to do fundamental research in both the field of analytics and process chemistry of cannabis to help producers and end consumers make better products.
Okay, and do you see, I've been reading up and researching a lot about creating your own cell line to use precision fermentation to create both psychedelic compounds and cannabinoid compounds. Do you see that as being the future of that, let's say the ingredient side of this industry?
So I'm a chemist, and therefore I will always talk down on a plant scientist and say, no, it's the post processing. But hear me out. So yes, grow environment, grow conditions, fertilizers can influence the chemical profiles the plants express. That is correct. So everyone talks about the strains or the cultivars of cannabis, but the grow environment is actually more influential than the DNA. So because what people care about is the chemical profile, so the chemovar of the plant. And I prefer to influence that in post-production. So when we harvest the plant, how do we dry the plant? How do we cure it? Then how do we extract it and then package it into the various products? And there currently is done so much in extraction that there's very little left over from the original chemovar fingerprint of the plant. And a lot of my research or our research is onto optimizing these extraction processes to better express the chemical profile of those plants in the extraction process and therefore in the final product.
Okay, so the extraction process is basically manipulating the end product to be as purified and exact as you want, and whatever about the initial flower was that you get to change and alter it so much that it's as clean as the biotechnology method, is it?
Yes, that's correct. So if you think about it in its basic form, the cannabis plant produces THC or a THC acid, and people care about THC because that makes them high. So how do you get it out of the plant, and how do you put it in a vape cartridge or a final product? If you only think about a single compound, then it's relatively easy. It's extraction and the purification. But when you think that cannabis is designed as a recreational product because of all the flavors and higher feelings one gets from them, pure THC doesn't do it. There's the interplay of various compounds. So now we have to track multiple compounds, and they all behave slightly different in extraction and purification, and it gets a very complicated multifactorial optimization problem. And there can be experience, there can be chemometrics to do this work, but it's all like a single dial at a time, new experiment process. So we then quickly shifted in our company to use machine learning because these algorithms can track way more variables at a time and optimize for all of them instantaneously. And so we work with cannabis producers to take in all their data, run it through our machine learning process, and then with Bayesian optimization, so if you want to look that up on Wikipedia, we then narrow down on the best method, and we can then optimize for yield, cost, purity, or flavor profile.
I actually wanted to move on to AI and cannabis next. Is a great transition there. Two things I had a question for an AI and cannabis. Is computer vision ever going to be something that'll be utilized to let's say monitor the health of a plant better than the human eye could do? And is machine learning capable of recommending, well, I suppose it's deep learning if you're recommending blends and formulations of different cannabinoids and terpenoids and flavonoids that may become future ingredients or products?
Actually, all of that is already happening. So we have our niche of AI and machine learning in extraction and cannabis analytics, finding new compounds. So we're using like language AI to interpret mass fragmentation patterns to find new cannabinoids and then track them. So it's really fun and cool for like the geeky chemist. But for your question on computer vision, so I've actually worked with 2 startup companies that used computer vision to track the health of cannabis plants. So they had cameras in the ceilings of grow rooms and would then monitor the plants and could spot pests or diseases earlier, so that a cultivator could then selectively treat that one plant or remove that diseased leaf before it spread through the whole room. And secondly, there's a company. So the first company was Deep Green AI. I'm not sure if they're still around, but they probably folded their technology in some other application. And then, but computer vision can also be used in other aspects. For example, trimming. So the cannabis plant is harvested, and the flower buds are then manicured with scissors to make this to have this nice shape and appearance for the end consumer, and that's quite labor intensive. So a friend, John Goa, had this company. Oh, sorry, now I'm missing the company. I will figure it out in a moment. So his company built robots that manicured cannabis flower buds into these nice end products. And to do that, they needed to look at the flower from all angles, understand what is flower, what is leaf, what needs to be trimmed, where does it need to be cut. And so they were training the AI, the computer vision, of interpreting what this robot is looking at.
That's pretty
And so his company, he then sold it on to like a larger conglomerate in the cannabis space. So this is still around.
Okay, very good, amazing. Quick question: is cryogenically frozen cannabis the best way to treat cannabis once it's fresh and grown?
Depending on what you want to do with it.
Okay, so inform me. Let's say we want to make flour as the end product, we want to make vape cartridge as the end product, and we want to use it as an edible. Is it suitable for all 3 of those, or is it perfect for just one of those?
No, so cryogenically frozen basically just means like freezing it really, really quickly.
Yeah.
So if you have seen the Batman movie with Mr. Freeze, that's cryogenically frozen. But it basically just arrests the plant, right? It's still wet, it's still fresh, it's just frozen in time. So if you now want to use ice water hash or keefing, so to separate the trichome heads that are rich or that produce all the cannabinoids from the rest of the biomass, then that is quite good because it's fresh, it's brittle, and you can easily remove them by agitation. But you can't smoke it because it's still wet. It's just frozen, but it's still wet, so you can't smoke it. You can do cryogenic drying, so freeze drying. So you freeze the material, cryogenically freeze the material, and then you go through freeze dry cycles, and those are potentially really beneficial to remove the water and keep more terpenes on the flower bud. So they would potentially give you a more flavorful, smokable product. And there are some companies in the space that are working on these aspects. Linde, for example, a gas supplier, they have some technologies in the space. And then lastly, is it useful for extraction? No, not at all, because extraction doesn't really want to deal with water. So you have the cannabis plant frozen, but it's still full of water. So for CO2 extraction that's done above room temperature, it would have to thaw anyway, and all the water just really throws the extraction out of whack.
What is the cannabis compound database? Why did you guys set it up, and why is it so important for the industry?
Sure, happy to. When I got into the cannabis industry in like 2014, there were like 4 cannabinoids known that people tested for. You could get basic standards for those, and that was it. And in the academic literature, you already knew about like 50, 80 compounds, and then over time it extended to like 150 different cannabinoids that are known. But nowadays you can only buy 16 reference standards, and testing labs only test for like 10 cannabinoids. So you see there's a big difference between like what information you can get on a piece of paper from the producer or from the testing lab and what actually is in the plant. And then there's research by Professor Dr. Mary out of Israel that really shows that it's beyond these 10 cannabinoids that actually have biological effects. So he did some anti-cancer screens where he found some really minor cannabinoids that don't even have names yet that kill the tumor, but THC isn't really doing the work. And so I was always intrigued what actually is in the cannabis plant, because if I want to do good extraction or get the right product for the right medical need, I need to understand what is in there. I can't just make a product where 80% of the ingredient is unknown to me. Right? I need to know what's in there. So therefore we just started scouring the academic literature and doing our own experiments to then figure out what different compounds are in the cannabis plant, hence cannabis compound database. So we just like hand curated that at the beginning, and now that we have better analytical tools in our lab with our language AI to figure out new cannabinoids, we then start adding them as well to our database, and we hope that this database can then be used by other people to look at their material or their spectra, their analytical runs, and compare it, and then maybe we can help them through that database figure out what they have in their material. So that's the basic idea.
Amazing. Yeah, it seems highly useful for the industry. It's been an absolute pleasure talking to you, Markus. I hope we get to chat again in the near future. For anybody who wants to learn more about Delic Labs, there's the website below. It'll be in all of the links on all the platforms that you're watching. So thanks again for taking the time, Markus. It's very much appreciated.
Great. Thank you very much.
Thanks, everybody. Till the next episode.